6.3, volume the shell method. Find the volume of a solid of revolution using the shell method. This one does not appear on the AP exam. I'm teaching this one to you not because it's necessary for you to know, but because sometimes it makes the problem easier for you. Sometimes a problem done with the washer method is doable, but easier if you use the shell method. And vice versa, sometimes you use a shell when a washer is easier. So here I'm just giving you options. If this is one you maybe skip through, so be it. You can get by with just the washers, but this sometimes makes your life a little easier at times. So we'll explain what it is. What's happening here, instead of going perpendicular to the axis of rotation, and then each slice you take out looks kind of like a donut or a washer if you're into construction. That's why they called it a washer. Instead of going perpendicular to the axis of rotation, we go parallel. And each slice you take out looks like a giant cylinder. And some people think of them as shells. They're shells that you stack together to get, or you accumulate these shells and you get this shape that you're revolving. And what you're looking at, if you think of these shells as cylinders, you're just looking for, you want the surface area of each cylinder, right? The lateral surface area. And to get the lateral surface area, you're going to need the height right here. And then going around like this, you need the circumference of your rotation. So it ends up being 2 pi r to get your circumference. And that r ends up being your axis of rotation. And then times the height, or how long that is. All right. So that ends up being 2 pi r h. And then the width of each of these would be your change in x, you change in y, or in the long run, delta y, delta x. All right, so let's look at a couple examples of the shell method. All right, find the volume of the solid formed by revolving the region bounded by y equals x minus x cubed and the x-axis about the y-axis. So let's graph this, take a look at it. All right, y equals x minus x cubed. Excuse me. We'll zoom to a decimal window, see how that looks. All right, so it's a pretty tiny region. All right. It says from 0 to 1. Basically, we're looking right in here. We want the volume when we rotate that around the y-axis. Now, what's nice about the shell method here is if we are going to use, let me just make the region bigger. If we are going to use washers, what would happen we would have to go perpendicularly axis rotation. And first off, we'd have to solve for x, because we're perpendicular to y, so we want it in terms of x. And we'd be going back onto the function that we are rotating around. That's not an ideal situation. So by going back, and instead going parallel to our axis of rotation, we can keep it in terms of x, so we don't have to solve for x. And we're not going on back onto the function. So our volume of a shell, or a cylinder, 2 pi rh times the width of our x's. Doesn't become d or delta or dx until after we integrate it. So 2 pi. And our window is going to go from 0 to 1, our limits. Now the radius of rotation, if our cylinder is here, this is our radius. If our cylinder is here, this is our radius. If our cylinder is here, this is our radius. Each radius is effectively whatever value of x you're at. So the radius will be x, and then the height will be these lines here, which the heights go up to the function. So our height will be the function, x minus x cubed. So our value there for that volume would be 2 pi from 0 to 1 of x minus x cubed dx. We can work that through. X squared minus x to the 4th dx. And we'll integrate it. We get 2 pi 1/3 x cubed minus 1/4 or 1/5 x to the 4th from 0 to 1. So what we got is 2 pi times 1/3 minus 1/5. 1/3 is 5/15 minus 3/15 is 2/15. So 4 pi over 15. All right, looking at another example or just a comparison, just some images that compare. Generally, most problems you'll give you are in terms of x. So when you rotate around the x-axis, usually you're going to use washers. Not always. This is just kind of a rule of thumb. And then when you're vertical, or when you rotate around a vertical axis like y, you want to use shells if your stuff's in terms of x, because then you don't have to solve. So here's another problem. Do with shells and disks and compare. We'll just do the setup. You can kind of compare from the setup. All right, so let's graph these. We got y equals x squared plus 1. Y equals 0, x equals 0. Those are basically the axes, and x equals 1. Zoom decimal again. All right, so we're basically looking for this region right here. As we rotate around, it doesn't say, I'm going to say x-axis. All right? Now, if we look at this, we're going to do the one that makes the most sense. Let's look at it and see if we're going washers or shell or disks. We're going to stack them like that, perpendicular to the axis. And as you see, the top is the function, the bottom is the axis, or the axis. And we're not going to have to solve for anything. So that's not too bad. Let's look at shells. If we look at shells, A, we're going to have to solve for x so we can get it in terms of y. And B, in this area right there, we're going to go from the line x equals 1 to the function. In this area, the top and bottom are different. So we're going to have to break this one into two integrands to get the two different sets on the graph. So this one definitely is best doing with disks or washers. So we'll go volume equals pi r squared from 0 to 1, where the radius is x squared plus 1 squared with respect to x. We'll go setup and calculate. So math 9 from 0 to 1 of x squared plus 1 squared with respect to x. I like an exact answer, so I'm going to convert that, and I'm going to say that that is 28 pi over 15. If you prefer decimals, just take your answer times pi, and we can say 5.864. Like I said, I am more for 28 pi over 15. And on the AP exam, when it says set up and evaluate, this is what it means. Here's your setup. Here's your evaluate. I just want those two steps. All right. Here they want the same region, this time around the y-axis. All right. I can kind of remember what that looks like, so I'll just go from memory instead of regraphing it. All right. So as we go around the y-axis, now again, we want our lines so that we don't have to go backwards from the function. We don't have to solve for x, so we have it in terms of y. In this case, it's best to do it in shells. All right, so if I do it in shells, their volume will be 2 pi RH times however wide we make our shells. We're going to stack them up from 0 to 1. Our radius, we're going to the x value. And our height is going to be to the function x squared plus 1 with respect to x. There's our setup. Let's evaluate. So math 9 from 0 to 1 x times x squared plus 1 with respect to x. Again, 0.75, which is 3 pi over 4, or if you prefer, 2.356. All right, one more. Actually, no, we're running short on time, the 15-minute time limit. I'm not going to be able to get through this. Try this problem. You can ask about it in class on Monday, Tuesday, or whenever I get back. So, volume using shells. Basically, you're looking at a cylinder. And you're looking at finding the lateral surface area of the cylinder. Just basically this face out front and around back. The lateral surface area would be 2 pi RH. And then you're going to add all those up, keeping in account the change in the width of your x. And as we integrate those, we get 2 pi times the radius of rotation in terms of x times the height of the cylinder or shell in terms of x with respect to x. And as always, you can go with dy as well.